Hello everyone, a very good morning to all of you. All the dear authors and the invited guests, a very warm welcome to the technical session 4A. Myself Yashita, and I'll be your moderator for this session. I'll be making sure that everything runs smoothly and maybe try to keep up your energy too. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 11th International Conference on Information and Communications Technology for Sustainable Development, which is ICT4SD 2026 Goa. The 11th edition of the conference is being organized in a hybrid mode, and the physical event is being held today in Goa, and the virtual event is being held through Zoom from 9th to 11th July, where people from all over India as well as many from other countries are present with us. So, I hope you all enjoy today's insightful and knowledgeable sessions. In this session, we will be having eight presentations, and each presenter will be given 10 minutes for presentation, followed by a 2 to 3 minutes question and answer session. I will be giving a gentle reminder at the 8th minute mark, just to keep everyone stay on track. Also, a small request to all the participants that please stay connected with us till the closing remarks. We will promise that this session will be worth it. If you have any sort of queries or updates to give, please feel free to drop them in the chat box anytime. Me and my co host will be addressing them. Before we begin, I would like to introduce everybody to our esteemed session chair for today. We have with us Professor Debraj Chatterjee, who is an assistant professor in Department of Computer Science and Engineering at Techno International Newtown, West Bengal, India. He has published numerous research papers across international journals, conferences, and book chapters. His research interests include computer vision, deep learning, and software engineering, contributing to his strong academic and research profile. Welcome to the session, Debraj sir. We expect you to give some sort of remarks to start this wonderful session.
Very good morning to each and everyone. Thank you, Ishita. This is, I think, the 11th ICT for SD 2026 in Goa, and it's very good to be here to listen to new ideas of the different session candidates who are present here. I welcome all of you here, and I'm waiting for your presentations. Thank you. Thank you very much.
Thank you so much, sir, for those words. We will begin with the presentation. First, we have with us Mudra Doshi, who is here to present her paper titled as A Decentralized Framework for Secure Healthcare Data Management, Leveraging Blockchain and Machine Learning for Intelligent Clinical Insights. Are you present, Mudra?
Yes, I'm present.
Yes, so you can start presenting your screen.
Yes, one second.
Mudra, are you ready? I think you're unmute. Sorry, mute.
Am I audible?
Yes, yes, you're audible. You can start.
My screen is visible?
Yes.
Thank you. Good morning, everyone. I am Mudra Doshi, and I am presenting our research title is a decentralized framework for secure healthcare data management, leveraging the blockchain and machine learning intelligent for intelligent clinical insights. Uh, Vaibhav Naravde sir is my project guide. for the PhD work. So today I am going to cover the following points: introduction, problem statement, research gap, objectives, literature review, architecture designing, which is a proposed architecture, experimental results, and finally the conclusion along with the future directions. Healthcare is becoming a increasingly digital and widespread adoption of the ethical electronic health records. However, the patient's information is still distributed across the multiple hospitals, laboratories, and diagnostic centers. This fragmentation leads to incomplete medical histories, delays in a treatment, and increase the chances of medical errors. Traditionally, centralized system also suffers from the security vulnerability, privacy concerns, and limited interoperability. Although AI can improve the healthcare decision makings, cloud-based AI services introduces the additional privacy risk because the sensitive patient information must leave the healthcare organization. So, problem statement for the research work is the existing healthcare ecosystem faces a four major problems. First is electronic healthcare records are fragmented across the different healthcare provides. Second, as a centralized database becomes attractive targets for the cyber attacks and the unauthorized attacks. Third, different healthcare systems cannot easily exchange their medical records due to the poor interoperability. And finally, the centralized architecture suffers from scalability limitations and a single point of failure. So, what are the research gaps? It says that from our literature survey, we observe that the existing studies typically focuses on only one aspect, such as blockchain, IPFS, or machine learning. Very few studies integrated all this technology into the one unified framework. So, moreover, the existing solution rarely supports the privacy preserving AI and decentralized healthcare analytics simulation. This research attempts to bridge the gap between the machine learning and the blockchain. The objective of and our contribution will be as follows. Our research makes a four major contribution. First, we develop a decentralized healthcare framework using a hyperledger fabric and IPFS. Second, we integrated a locally deployed llama model for privacy preserving clinical intelligence without relying on the cloud AI. Third, the machine learning techniques enables the disease prediction, patient risk assessment, and healthcare resource management. And finally, the smart contract encryption and blockchain significantly improves the system security and scalability. So this will be the literature from the papers. We got this one of the system architecture. The figure illustrated the typical blockchain-based healthcare architecture from the existing literature. The previous research demonstrate the benefits of the blockchain ensuring the data integrity and the security. However, the many existing system, the lack of intelligent analytics, decentralized storage, and the privacy preserving AI. This limitation motivated the development of our integration framework. So, what we have done it. So, different stakeholders will be there. I will show you the diagram as well. This will be the implemented diagram. Patient information is collected and encrypted before the storage. The medical files are stored in the IPFS, while on the hash values and metadata are stored on the blockchain. Smart contracts verify the user permissions before data access. Authorized users retrieve the verified records, and local AI model performs the disease prediction and clinical summarization. This architecture ensures the confidentiality, integrity, and the availability and the transparency. So the next slide shows the comparison of the existing system. We compared our proposed framework with the Ethereum-based and the Fabric-based healthcare system. Ethereum provides the relatively low throughput and the scalability. Hyperledger Fabric improves the performance but offers only a partial AI integration. Our proposed framework achieves the approximately 1600 transactions per second while providing the stronger security, high scalability, and intelligent machine learning capabilities. The again next slide shows the clinical summarization of the efficiency. We evaluated the efficiency of the different clinical tasks. Manual clinical review requires several minutes. Cloud-based GPT model significantly reduces the excuse time for the required transition and the sensitive patients data over the internet. Our locally deployed llama model performs even faster while preserving the patient privacy because all the processing occurs within a healthcare environment. So this will be the advantage of the my current system. That is, a framework provides a several important advantages. That is high security through a blockchain and encryption, high scalability using decentralized IPFS storage, privacy preserving AI through locally deployed Llama, transparent access control using a smart contract, improve the interoperability across the healthcare organization. Overall, the framework provides the secure and intelligent healthcare data management. So, in conclusion, we proposed a secure, decentralized healthcare framework integrated with the Hyperledger fabric, IPFS, and machine learning. The framework enhances a privacy, interoperability, scalability, and intelligent healthcare analytics. Our experimental evaluation achieved the approximately 93% prediction accuracy and around 1600 transactions per second demonstrated significantly improvements over existing approaches. Furthermore, will focuses on federated learning, Internet of Medical Things, integration, explainable AI, and deployment of across the multi-hospital healthcare networks. These are the few references I have added. Thank you very much for your valuable attention. I would be happy to answer any questions or any discussion aspects with the research.
Thank you so much, Mudra, for your presentation. Devrat sir, do you have any
Yes.
questions for?
Yeah. You have used here, ma'am. Hi, good morning, ma'am. You have used here one method of LLMA where you are getting some accuracy of 93%.
Sir, your
And
voice is breaking.
uh, okay. Now, ma'am, can you hear me?
Yes, sir,
Hello.
you're
Yeah.
audible.
Yeah. Ma'am, the question is you have used your method of LLAMA and you are getting an accuracy of 93%, right?
Right.
So, is there any other method which is previously used which are going up to this level of accuracy? Have you
No.
checked that?
I have checked with the naive-based algorithm. The basic algorithm with the machine learning, I have used it. Two algorithms, naive-based, I have used it,
Okay.
and
And
SVM, I have used it.
okay.
But these two algorithms are not giving the result which I am getting it with the Llama model.
Okay. Have you checked the precision for that, ma'am?
Sorry.
Have you checked the precision
Yes,
regarding
yes,
this? Yes.
yes, yes, sir.
Can you tell me the percentage, ma'am, for the precision? Means if you had that in your hand right now.
No, actually, I don't have it in
Okay,
hand.
okay, no problem, ma'am. No problem. Thank you, ma'am. Thank you.
Yeah,
Yes,
thank you.
Nita, continue.
Okay, thank you so much, Mudra.
Welcome. Thank you.
Yeah, so let's move with the next presentation. We have Mahak Agarwal to present her paper titled as an IoT enabled smart hydroponic system. So, Mahak, are you present?
Yes, ma'am.
Yes, you can start.
Good morning, everyone. I'm Matt Agrawal, and today I'm privileged to present or research paper on the behalf of my
Excuse me,
entire team.
your presentation is not visible.
Let me check.
I think you are not presenting the screen.
Yes, ma'am, there is some technical issues with my screen sharing. So my teammate is presenting the screen.
Oh, okay, okay. Abhinav, right? Abhinav, you can present again. Try to represent, please. Yeah, the PPT is not visible, but we have to share the entire screen. Abhinav, only the meeting is visible. The presentation is not visible. So you need to click on the presentation window when you click on share screen. Mehak, you can try once again, or else you can resolve that issue and we can move forward with the next one and then take you again.
Yeah. Okay, ma'am, no issues.
Okay, so you will resolve it. So next we have Preeti Sagar. Are you present, ma'am?
Yes, ma'am, I'm present.
Yes, so
I'm
she is
sharing
here
my
with
screen.
us to present her paper titled as A Novel Hybrid Stylometric Model for Disputed Words Detection and Authorship Attribution in Kosher Poetry. It is a very interesting
Ma'am,
topic, I
are
must
you
say.
able to see my screen?
Yes, yes.
Okay. So, my topic is a novel hybrid stylometric model for disputed verse detection and authorship attribution in kosher poetry. So, before I start, I just want you to give a brief introduction about the what is kosher poetry. So, we will start with the introduction and the scope of the research, then the objectives, and then we will move towards the data sets descriptions, methodologies which I have implemented, results which I got, and my work and the future contribution, future research which we can do. So first I'll try to explain what is kosher poetry. Kosher is a language spoken in the northern part of India, which is known as Kashmiri. So Kashmiri language is known as kosher. It is my scope of the project is that my scope is Kashmiri poetry. I have considered the Kashmiri poetry, which is written in Devanagari language. And stylometry I have applied on two famous poets of 14th century, that is Lal Ded and Nund Rishi. These were the famous two poets of kosher poetry. So my corpora I have taken the corpora of these two poets and I'm doing the stylometric analysis of these two poets. Now we will understand what is stylometry all about. Stylometry is basically a science which helps us to understand the writing style of the authors, how the authors write. Every author, every writer has its own style of writing. So stylometry is a branch of natural language processing which is helping us to understand how the authors are writing, what are their writing styles. And once we understand the writing style of the author, we can come to know who is the author of this unknown point. If there are certain points which are not attributed to some authors, we can assign the authorship to these kinds of points after doing the stylometric analysis. So my objective of the study is to identify the disputed verses among the two poets and assign authorship. Actually, there is a problem that these 14th century poets have written lots of verses, but there are certain verses which are common in both the poets. So it becomes contradictory among the literature people that who has written which verse. So my job is, what I am trying to do is to identify to first of all I will study the style through stylometry. I will study and analyze the writing style of these two poets, and then I will find out I will assign the authorship to the disputed verses. So my research is going into dual phase. The first is to identify and classify the disputed verses among the two kosher authors. So first I will identify the disputed verses, and then I am going to show you the results among the two. So data set here used is the original data set is from the Lalla author I have taken 261 points, and from the Nunda author I have taken 288 points. So total 549 points were considered, which is the from the original data set. And I have used the synthetic data set also, just to make sure that how it works, and just to ensure that there should not be any problem with the models. They get trained well. The 549 should not be the less data set for them. So I have included 326, 166 synthetic points also. The methodology here is first of all we have to submit the original corpora to the system. So original corpora will get divided into two, the Lalvak and the Nundashuk. We will distribute the data sets into two parts. After doing the pre-processing, applying the ratio of 660, so we will find out, we will normalize both the data sets, and then we will apply TF-IDF and find out the similarity index among the two. If the two authors, we will find that two verses are similar, and the similarity score is greater than 75, we will put them into the disputed verses. So once we find out the disputed verses, we will apply the character level TF-IDF and the stylometric features which I have extracted. We have extracted some stylometric features from both the authors, and after implementing and the machine learning algorithms will tell us which poem is written by which author. So to understand it a little in a better way, I have considered one example so that we can understand it in a little better way. So the first thing is to take the data processing and script validation. It is very important to know that the script which we are taking is authentic. I mean, there are lots of symbols, characters which are there, which are not actually written in the Devanagari script. The first thing is to take the authentic Devanagari ratio. So I have calculated the Devanagari ratio first of all. Then I have filtered the length of the verses. It should be minimum 8. The verse length should be minimum 8, so that we can consider it for the stylometric analysis, because it needs a good number of lines. And then after applying the character level TF-IDF with 3 to 5 n-gram ratio, I have calculated the verse length, word count, type token ratio, and hapax ratio, so that we can understand how a poet is writing, how many words he is using per line, how many lines he is using in a particular poem, and how he is putting the full stop, commas, and in Hindi we normally put halat, we put dandas, where he is putting, what is the rhythm of those things. So we are identifying those, and after these will go into the feature extractions, and after that we are putting the ratio of 75%. If the two verses are identical in 75% ratio they are identical, then we will consider them as the disputed verses. And after applying the machine learning algorithms on this, we can bifurcate these. So when we got the results, we find that 24 disputed verses, the machine has found out 24 disputed verses. And when we are dividing those 24 disputed verses, the results is something like this. The system identified 24 verses as disputed, and we provided the authorship also. The system also provided the authorship to these 24 disputed verses, where 9 verses goes into the lull category and 15 falls under the nund category. And there was some ambiguity also. There were 3 verses which were not coming, which were very close to the ratio. Actually, the ratio was 50%, but it was coming very close to that, and the system recognized those also. Accordingly, I have put the results, and these are the results of the applied machine learning algorithms. These are the algorithms, machine learning algorithms, which I have applied, and among all, linear SVC was the highest performing algorithm, followed by multi-layer MLP, multi-layer perceptron, and multimodal NB. These were the top 3 models, with the linear SVC giving the highest accuracy of 87.2%. So I have applied the same on the synthetic data set also, just to ensure that how my data is working and how it is, how my machine learning algorithms are giving the results. So this is the data for the synthetic, this is the results for the synthetic data set, where again linear SVC was the highest performing model, with followed by MLP, and here it was XGBoost. So previously it was multinormal NB, and here it was giving the highest was giving by XGBoost. So this is the results. And the conclusion is that stylometric analysis I have implemented with 10 machine learning algorithms in 2 phases. In the first phase, I have just identified the disputed verses first of all among the 2 authors, Lalla and Nund. And in the second phase, I am assigning the authorship to these 24 disputed verses, and it resulted in a very good results were there. And for in languages, we normally authenticate the data with the language experts, annotators normally. So I have used the annotators also in my research, and they were 100% agreed that my research, my results are up to the mark. So this was my research all about. And in future, what we can do is we can increase the data set for stylometric analysis. We can include more authors. Here I have included only 2 authors. So we can include more authors, and we can use advanced machine learning algorithms, deep models, deep learning models we can implement in the future. Thank you so much.
Thank you so much, Preeti. Devrat sir, do you have any questions? Okay, I think there are no questions from Devrat sir.
Okay.
So we can move forward
Okay, I'll stop
with the
sharing.
next. Yes, sure. Okay, so for our next presentation, we have Monica Jain with us. Monica, are you present?
Yes, ma'am.
Yes, so she is here to present her work titled as A Review of Intelligent Deep Learning for Skin Cancer Classification Systems, Challenges, Datasets, and Future Directions. So, Monica, are you ready? You can share
Yes.
if you're ready. Yes.
Yes, ma'am. My name is Monica Jain. Are you audible, ma'am?
Yes, you are audible. You can start the presentation. You have
Okay.
to do it in the presentation mode, please. The slideshow.
Yes, sir. Good
Yeah.
morning, everyone. My name is Monica Jain, respected chairperson, esteemed panel members, and all attendants. Today, I am presenting my MTech thesis title is Automated Dermoscopic Image Analysis for Early Skin Cancer Detection Using Deep Learning. Skin cancer is one of the most common types of cancer worldwide. Early detection plays a crucial role in improving treatment outcomes and reducing rate. Now, first of all, introduction. Traditional diagnosis mainly relies on visual examination and dermoscopic analysis by dermatologists, which can be time consuming and may sometimes be subjective. To address these challenges, my research focus on developing an automated deep learning based system that analyzes dermoscopic image and assist in the early detection of skin cancer with high accuracy. In this presentation, I will discuss the problem statement, objective methodology, dataset use, proposed deep learning model, experimental result, and the conclusion of my research work. Now, first of all, introduction. Cancer is a disease characterized by uncontrolled cell division where malignant cells invade nearby tissues and spread to distant organs, potentially leading to death. Now, next, increased exposure to ultraviolet radiation due to ozone layer depletion, as reported by World Health Organization (WHO), contribute significantly in the rising incidence of the skin cancer. The four most common type of skin cancer is first one is melanoma, second one is BCC based cell sarcoma, third one is NMSSC, and fourth one is SCC. Now, skin cancer diagnosis typically involve visual inspection, dermoscopy for enhanced lesion analysis, and bioscopy for microscopic examination of suspicious tissues. Now, in this, the ABCD rule first is asymmetric border, color, diameter, and evaluation. Now, early detection and diagnosis are essential for reducing mortality, preventing metastatic, and lowering treatment costs, while manual diagnosis may be time consuming and prone to the human error. Now, AI-based computer-aided diagnosis system use deep learning, improve early detection accuracy, assist dermatologists in classification tasks, and enable accessible, cost-effective skin cancer screening through automated image analysis. Now, next one is skin cancer. This figure is first one is human skin layers. First figure in the many types of human skin layers. Second is the sample images of skin cancer classes. In this figure, different type of skin cancer classes, and third one is skin different types of skin cancer. Now, next, deep learning technique for skin cancer detection. In this, the skin cancer detection using deep learning technique. First one is CNN architecture. Second one is reset network. In this, the reset network, and the third one is the dense net network. Now, next one is research questions. In this, the many types of research question are there. Now, next, objective. First one is to collect and organize a publicly available skin cancer ISI dataset suitable for automated skin lesion classification and experimental evaluation. To increase data quality and model generalization, you should do data pre-treatment and enhancement tasks, including image normalization, resizing, augmentation, and management of class imbalance. Third one is to create and deploy a DL-based, deep learning-based classification algorithm that can learn distinguishable visual characteristic from microscopic image of the skin. To determine the effectiveness of the implementation framework by computing its F1 score, recall, accuracy, and precision, which are typically metrics for classification. Now, to show the usefulness, the established framework as a supporting tool for skin cancer detection in clinical decision making. Next one is scope and signification. First, in the scope skin cancer detection, focus on leveraging a publicly accessible dermoscopy image dataset for automated skin lesion characterization. Second, develop and implementation DL-based classification. Third one is analysis multiple types of skin lesions. Fourth one is limited to offline analysis and experimental validation. Fifth one is does not include clinical trials, real-time deployment, or patient-specific diagnosis. Next, aim to support dermology decision support system. Now, next, not intended to replace professional medical expert. Now, next is significance. Address the challenges of the accurate and reliable skin lesion classification. Next, enhance diagnostic consistency by reducing variability in manual assessment. Now, next, improve reliability of automated skin cancer in using DL method. Contribute academically through inside the processing technique. Now, next, provide comparative evaluation of deep learning model. And now next, promote early detection and improved clinical evaluation of skin lessons. Next one is literature review. In this skin cancer detection mein literature review, this is many type of literature reviews. Now research gap. In this the research gap, limited focus on early and preclinical lesion detection despite its high clinical importance. Poor generalization of method to real world clinical setting due to reliance on control benchmark dataset. Dataset imbalance and innovation variability affecting model reliability and reproducibility. Next, lack of integration between the clinical method and the image features. Now, next, limited explainability and transparency in deep learning models. Next, overemphasis on accuracy while unreporting clinical critical metrics such as sensitivity and false negative. Now, next, high computational complexity resisting deployment in resources constrained environment. Now, next, limited research on multi-class and fine-grained lessons classification compared to binary classification. Next one is research methodology. In this, the features proposed methodology flow chart of the proposed methodology for multi-class skin lesson. First one is collect ISI skin cancer dataset. The second one is data pre-processing. Now label encoding, data construction, class imbalance handling. Now next data set splitting, data augmentation, final encoding, model development. Now next model training, performance metrics, and end. First one is data collection. The study of 2356 dermoscopic image of winning a melanin skin lesson ISI skin cancer dataset are collected. Second, data pre-processing. First one is hair affected removal. In this, the hair affected hair occlusion are removed using grayscale conversation, black hat more political operations, thresholding and tele in painting to resort affected regions without losing lesson information. Next one is color normalization. Find out the where is the color normalization, the lab color space. Next, lesson localization and segmentation. Image resizing. In all image are masked or resized or 2 to 4 into 2 to 4 pixel and ensure uniform input size and compatibility with deep learning method. Next, label encoding. Skin lesson categorized are converted into numerical labels, enabling efficient model training and prediction interoperation. Dataset constructions. After pre-processing, images are stored in the standardization NumPy arrays with corresponding masks and labels.
Monica, just a quick reminder, you will have to wrap up within next 1 minute because it's already time.
Yes, ma'am.
You have to wrap up within next 1 minute because it's already time up.
Okay.
Yes.
Yes, ma'am. Now, simulation and platform for implementation. In this, the Python tools and key Python libraries and frameworks, NumPy, SciPy, scikit-learn, TransformFlow, Keras, PyTorch, and Matplotlib. Jupyter Notebook. In this, the Jupyter Notebook is our open source web-based environment used for developing and documenting research workflows. It allows integration of course, visualization, text, and result of a single interactive platform, supporting reproducibility, collaboration, and transparent signify communication while aligning for fair data principle. Now next is result analysis and discussion. In this the figure dermoscopic image across skin lesson classes, various type of skin classes, actinate keyboards, number of images 130, base cell ceramina 392, dermatologist femina 111, melanoma 454, nevus 373. In various types of skin result are there. Data visualization of ISI skin cancer dataset. Two figures are there. First one is data analysis visualization of the dermoscopic skin lesion. Second one is distribution of skin lesion image classes in the dataset. Experimental result of hybrid with multi-fusion architecture. Various type of figures are there. In this, the with multi-fusion architectures, training performance. Now next in classification report, conclusion matrix, next ROC curve, and the last one is sample prediction visualization. Model performance comparison. In this, a model performance comparison Compare hybrid VIT multifusion and EffectiveNet lightweight models showing strong performance across all metrics. Hybrid with multifusion across 94.87, accuracy 95.36, and precision 95.19. Recall 94.89. F1 score 0.9954 AUC, indicating balancing multi-class classification despite higher loss lightweight. Now, next one is conclusion. Develop a multi-class skin cancer detection algorithm using deep learning trained for ISI dermoscopic dataset. Apply extensive pre-processing, including hair effect removal, class score normalization, lesson segmentation, and standardization resizing. Address class imbalance using random oversampling on the fly data augmentation to improve generalization. Now, next one is develop efficient net bio lightweight model integrating pretending efficient net features, achieving a strong performance, hybrid with multifusion and research 94.87, accuracy 0.9954, and efficient net when show slightly higher accuracy with lower case. Next, demonstrate high classification reliability with minimal multi-classification, showing strong quotation as a clinical decision support tool in the dermatologist. Next one is future work. Future work. In this, the skin cancer detection future work is first one is clinical metaset integration. Next, advanced lesson segmentation, usually fully supervised deep learning model. In this, the skin cancer detection. Next, explainable AI. Applying method like GRADE, CAM, and CHEF can improve model transparency and increase clinical trust. Next one is real-time and mobile deployment. And now next, cross dataset and clinical validation. These are many types of references are there. Thank you, ma'am.
Okay, thank you so much, Monica. Debraj sir, do you have something to say? Yeah.
Good morning, ma'am. Ma'am, I have one question. Which method you have used in this procedure, in this carcinoma cancer? Which method you have used?
Sorry, sir. Your voice is not clear.
In this process, which
Yes,
method
sir.
you have used to check the accuracy of the cancer carcinoma?
Yes, sir.
Which method you have used?
Deep learning method, sir.
Which algorithm, ma'am?
What, sir?
Means deep learning is a large thing. Which algorithm you have used? Any specific algorithm you have used here?
Deep learning method, sir.
Any classification methods you have used or checked?
So first one is image collection, classification image collection. Now next one is pre-processing, then feature abstraction.
No, ma'am. I'm asking you any classification method you have used, like name-based classifier or anything like that you have used here?
So I am not have any information.
Okay, okay. Thank you, ma'am. Thank you.
Thank you, sir.
Thank you, Ishita. You can continue.
Yes, sir. Thank you so much. So our next presenter is Smriti Dwivedi. Are you present, ma'am?
Yes, ma'am.
Yes. So she is here to present her research paper titled as Design and Simulation of Elliptical MIMO Antenna with a different DGS for beyond 5G applications. So Smriti, are you? Yes, you can
So,
start presenting.
sure, ma'am. Thank you.
Yes.
So, very good morning to all of you. I'm Smriti Dwivedi from IIT BHU. So, I'm going to present my paper on the topic of design and simulation of elliptical MIMO antenna with different DGS for beyond 5G application. So, under this topic, I'm going to summarize these outline like antenna basics, microchip antenna, advantages, disadvantages, about some frequency range, design of antenna, results, conclusion, and references. So, presentation roadmap is like problem, context, and motivation, design, progression, and methodology, geometry, dimension, DGS concept, simulation results for all three structure, and comparative discussions, also the limitation and future work. So in this paper, the paper actually based on the elliptical patch antenna and 2 cross 2 MIMO variant using a defected ground structure for beyond 5G application. Here I have used a copper radiator on FR4 with the inset feeding, and the operating frequency range I have taken 3.6 to 5.8 gigahertz. The core objective of this paper is to improve the gain as well as bandwidth while keeping the antenna geometry simple. So this work is very good for beyond 5G link, and this is actually we are using to get the higher bandwidth and better channel capacity. MIMO topology increased throughput and reliability with the DGS can improve matching as well as the radiation performance. So we can have a very less loss in this structure. So before going into detail, we have some antenna basics. Why we do antenna? Because antenna is very much important when two people wants to communicate and they are separated apart. And we can use the antenna as a radio receiver as well as a transmitter. Here we actually send the electromagnetic signal with the velocity of light. So we can use the antenna underwater as well as through soil, rock at the certain frequency for short distance. Now we have a 6 different types of antenna, but I am going to use the patch antenna under this design. So basically we have certain advantages and disadvantages related to the microchip antenna. So advantage, if I going to talk like lightweight and low volume, low fabrication cost, polarization radiation is very low, and it is compatible with the MIC design, but it has a certain disadvantages. That's why I am moving toward some changes in this particular patch antenna, because it is having a narrow bandwidth and low efficiency, which is the most dangerous disadvantages associated with this patch antenna. So basically beyond 5G or 6G frequency, so we have a sub 6G, millimeter wave, sub terahertz and terahertz vision. But in this paper I'm going to use only 3.6 to 5.8 gigahertz frequency. I'm not going to use the high frequency here. So basically if we talk about the terahertz or millimeter or microwave frequency, basically today the people are actually researching in the field of terahertz, and terahertz is actually 0.1 terahertz to 10 terahertz. And if you talk about in terms of wavelength, it is actually 3 millimeter to 30 micrometer. So we actually categorize the terahertz in two different simple frequency range, like sub-millimeter radiation and infrared. Also 5G technology supports the beam division multiple access, and it has a low latency. That's why we get the very good camera quality as well as the sound. So basic thing about the terahertz or microwave or millimeter is to design the antenna. So it is basically I have actually researched so many papers, and there I have got few concept that I have used in this paper. So we have a meta material, graphene, gold, and these are actually expensive materials. So I have used only the copper, which is a simple material and cheap material, and I have used the simple structure, not going towards a more array structure or nanomaterial property. But there are several paper, but they did not give the fabrication of these antennas. So design progress and use in this paper. First I have used single elliptical patch with the 1 DGS, then I have moved toward a 2 cross 2 MIMO with DGS and 2 cross 2 MIMO with DGS2. So it is these are some parameters that I have taken. Actually I have taken a feed type, which is 50 ohm inset feed, and material I have used for the patch and the ground I have used copper, and for the substrate I have used FR4. FR4 is basically a cheap substrate or dielectric. So design and simulation of antenna, this is the first structure I have taken, and here basically I have used DGS1 structure. Now in this structure I have actually calculated the S11, that is called the return loss as well as gain, before moving a second design. So this is the S11 plot. In the left side I have a S11 plot which is having minus 33.4 dB, which is actually very good, and the reported gain from this antenna I have got 3.16 dBi, and that I have calculated using a right side plot, that is a radiation pattern. But this design actually giving us a low gain. So I have moved toward a second design. The DGS is same, only the I have used 2 cross 2 elliptical structure. In this design actually we have a gain which is actually improved, and according to this S11 parameter radiation pattern and gain, here the gain I am getting 5.71 dBi, which is more as compared to the previous one. And this MIMO layout actually the major source of performance improvement under this study. So now the third design I have used, I have taken 2 cross 2 elliptical structure as the same structure, but I have changed in the DGS, that is the defected ground structure. And in this structure, the additional ground engineering in this paper is the final optimization step, and it is giving us the best result as compared to the two different previous structures. So here I am getting a 6 dBi gain, and it is the best possible structure with the simplicity as well as the low fabrication cost. Now this is the equivalent circuit diagram for all three structures that I have drawn using a ADS software. Now this is the comparison table of the proposed structure. So in the first one I am getting 3.16, and the second one I am getting 5.71, in the third I am getting 6 dBi. So this is the gain comparison of three proposed structure. That is actually a very accurate plot bar chart. From this chart we can actually calculated all the gain. Now the bandwidth and performance is, of course, the bandwidth is improved from 2 gigahertz to 8 gigahertz, and better gain we are getting. Further we can improve the gain by using a DGS modification, and also this DGS modification can improve the matching as well as the it will give a low loss. Now this design are very important because it is a very simple design. It can be easily fabricated, and it can also the material that I am using, it is very cheap as compared to the gold, silver, graphene or other costly material. Now advantages of this work: simple geometry, straightforward fabrication part, low cost FR4 and copper implementation, clear performance progression from baseline to optimized design, and further it can be good starting for the higher order MIMO antenna development. So this is the conclusion that I am getting from this paper, that the paper present a clear three-step antenna evaluation, then reported gain improved from 3.16 to 6 dBi, and the final DGS2 based MIMO design is the strongest candidate for beyond 5G structure. So these are the references that I have used for this paper, and thank you so much.
Thank you so much, Smriti, for presenting. Debrat sir, any questions from your
Yeah.
side?
Good morning, ma'am. Ma'am, your presentation is good enough. Ma'am, the question is there any major change in using this business to MIMO in the signal? Is there any
Sir,
change in the Yeah.
can you
I'm saying,
yes sir.
is there any major changes in the signal patterns while you are using this DGS to MIMO?
Yes, sir. Actually, I'm getting a less reflected wave, and standing wave pattern is more clear. And from actually VSWR is the most important parameter, voltage standing wave ratio, which actually gives us how much reflection we are getting from receiver to transmitter. So in the third structure, I'm getting very less reflection. That's why my S11, that is the return loss, is improving. And also we can implement more structure in DGS. We can change in DGS. So but actually I haven't checked more than two structures, so it may be possible that I will improve the gain.
Okay, so it is actually affecting the bandwidth also, right?
Yes sir, yes sir, bandwidth
So
also.
yeah, so how what is the basic difference between the previous bandwidth and the new one after the use of this one?
Actually, from the first structure, I'm getting around 2 to 3 gigahertz bandwidth. But from the final structure, because I'm using 4 2 cross 2 MIMO structure, so because of 4 radiator, I'm getting more than 2 resonant frequency. That's why the second resonant frequency that will actually improve. And from 2 to 3 gigahertz, I'm getting now the 8 gigahertz. So resonant frequency is improved.
Okay, okay. Thank you, ma'am. Thank
Thank
you.
you, sir. Thank
Okay,
you.
continue to Yashita.
Thank you so much. So our next presenter is Heap L3. Are you present? Okay, so I think let me check once. Okay, she is not present. So, Mehak Agarwal, we were left with your presentation. Are you there? Are you ready? I think she. Mehak. Okay, I think she's not there. So we will move forward to KP Uday Krishna. Are you present,
Yes,
Uday?
ma'am.
Yes.
Yes, yes, yes.
So he is here with us to present his paper titled as Detection of URL based phishing attack using LLM and explainable AI. So are you ready, Krishna?
Yes.
Yes, you can start.
Is my screen visible, ma'am?
No, it is not visible. Yes, now it's visible. You can start.
Just a second.
Yes.
Just.
Could you please reshare?
Yeah, yeah, yeah.
Yeah.
Uh,
Yes, you can start.
just a minute. Like it's visible properly, right, ma'am? Like I'm changing the screens.
Yes, it is visible. Yes, yes.
Yeah. So good morning, everyone. I am Uday Krishna. Today I am presenting my work on title URL-based phishing attack detection using LLM. So as you all know, phishing is one of the most common cyber attacks today. Attackers create fake websites or URLs to steal sensitive information such as usernames, passwords, and banking credentials. So, like nowadays, the traditional phishing detection methods mainly depend on blacklist database or conventional machine learning algorithms. Just that. Although these methods perform reasonably well, they often struggle to detect newly created phishing websites and usually cannot explain why a URL is defined classified as phishing. This is the main thing in my work. So, therefore, this work explores the use of large language models to improve both phishing detection and explainability. So this is my previous work. In my previous work, then the initial work I used an ISCS URL 2016 dataset to classify the URL as phishing or benign. Then used Lime to generate explainability. In the beginning, I used T5 small model, and using the T5 small model and Lime, I generated explainability and good accuracy. The result was good. It achieved an accuracy of 96%. Then I got like another idea, like my few in the future I changed it to develop a dynamic explainability mechanism integrated directly into the LLM model. I fine-tuned the LLM model, use LLM using a phishing dataset with line generating explanations to enable simultaneous prediction and explanation generation. It improved the contextual and semantic relevance of generated explanation for better interpretability too. So then I created a comprehensive system for real-time phishing detection, tailored human-readable explanations. This is my first initial work architecture. Initially, I used the input feature extraction module, input layer, feature extraction module. Then used that and extracted some features query length, token count, path count, path token count, extra, etc., and gave it to the T5 model. And in one side, I used Lime for generating the explanation. That is this layer, explainability layer, Lime analysis feature importance. I used Lime for the to run locally and get the explanation. And at the same time, I used the T5 model for classification. Then I got the then the T5 model is fine-tuned, get the final output. So now my main problem, coming to my current work, my main problem statement. In my existing phishing detection models mainly focus on classification. They simply predict whether a URL is phishing or legitimate. However, they do not explain the reason behind their prediction. My objective is to build a model that not only detects phishing URLs but also provides meaningful explanation. To achieve this, what I first did was like trained a machine learning classifier, generated the Lime explanation, then added the Lime explanation into the dataset as a new column, and then fine-tuned my T5 small model using this enriched dataset. So basically, what are LLMs? LLMs are large language models or transformer-based deep learning models capable of understanding and generating human-like text. Unlike traditional classifiers, LLMs understand contextual relationships. Because T5 follows a text-to-text architecture, it can perform both phishing classification and explanation generation in a single framework. So I use this capability too. So this is the data set preprocessing. In data set preprocessing, what I did was I used ANOVA FTEST algorithm to get the top 10 influential features, then use the random forest classifier to identify key factors and get the line generated explanations. That was the beginning. After that, the missing or non values in the data set were handled by using imputation techniques, replacing missing value with mean or mode of the respective feature. The final data set was prepared with 10 features, free of missing values and balanced for training a machine learning classifier. After training the machine learning classifier, Lime generated explanation for every prediction. These explanations described why a URL was classified as phishing or legitimate. Instead of discarding these explanations, we converted them into readable text and stored them as an additional column in the dataset. This enhanced dataset became the input of training the T5 small model. Then training the LLM. The dataset containing both features and explanation used to train the large language model. The LLM is fine-tuned to understand both URL features and associated textual explanations. So then I made it like to generate meaningful explanations. I custom tailored it, but it could be improved. For giving different explanation for each rows, that might increase the predictability. The main focus was on improving the transparency of the black box models and improving the user trust. So this is my main work architecture. So the data was pre-processed and top 10 features were selected using ANOVA FTEST algorithm. Then dataset was trained with XGBoost. The same data is used to generate explanation for each XGBoost plus Lime. Then updated the dataset with readable explanation. Then the new dataset was created with the readable explanation. Then it was tokenized and it was given for the T5 small model for the fine tuning. After which it gets the prediction like output. The prediction was like phishing or benign with human readable explanation. So this is my accuracy level after this Lime explanation. Accuracy was 0.92 and precision was 0.92%. Recall was 0.91 and F1 score was 0.92, which was fairly good compared to other models and other models that was available. And this is my result output. So I entered the 10 values which was mentioned, like which was taken. After that, the prediction was like phishing. Then the explanation of like whether why it is determined as phishing or benign. And this is my confusion matrix. In here you can see, as you can see, the true positive rate, true negatives, false positive, and false negatives. True positive and true negatives are fairly high, and false positive and false negatives are fairly low comparatively. So we can say that my model performs consistently almost every time. So to conclude, this work demonstrates that integrating large language models with Lime explanation improves both phishing detection and interpretability. The proposed framework not only classifies phishing URLs accurately but also provides understandable explanation for every prediction. Future work will focus on refining the model more with real-time datasets because it's fairly difficult to get the phishing dataset uh, to create the phishing dataset because as you know the dataset like as the phishing web pages are removed almost very fast like it won't have much age the it will be removed fast so it is very difficult to create the dataset so it's a limitation of this so thank you like this is my work thank you and I am happy for any questions please.
Okay, thank you so much, Uday. Devraj sir, anything to say?
Yeah, good morning, sir. That was a nice presentation. So I have a question. You were using the LLM method for the phishing attack, for detecting the phishing attack.
S-
So
so
is
I
there?
couldn't hear it clearly sir.
Yeah, sir, I'm saying that you were using the LLM method to check for the
Yeah,
phishing detection. So is there
yeah.
any way out for using
Voice
web
is a
crawling
little bit
method?
low. Can you?
Web
Excuse
crawling
me.
method? Can we use
Web
there
scroll.
any other method using web crawling?
Yeah, actually, sir, that was also one of part of my idea. But the problem was like you for using web scrolling, there are many privacy issues
Yeah.
already because the privacy issues mainly be like you can't access all the website. Like you
Okay.
for that, like we may get
Because we have to download all
phishing
the
websites.
cookies. We have to download
Yeah,
all the cookies one by one, and that will breach the whole system. That will be a big
yeah,
problem. Yeah.
that's a big problem, sir. So we can get phishing datasets, but comparatively, the benign dataset will be very difficult to obtain because many good websites will never reveal their,
Yeah.
like it will
The
never
data.
allow for web scrolling. So that was a
Right.
big limitations by Mart. That's why I used URL based detection, sir,
Yeah.
rather than web scrolling methods.
Yeah. That's why I asked you the question. Okay. That's a
Yeah,
nice thing. Thank you. Thank you, sir. Thank you, Ishita.
Okay.
You can
thank you.
continue.
Yes, thank you so much, everyone. So for our next presentation, we have Miss Swati Nikam. Are you here, ma'am? I'll check once. Okay, any of her co-authors is present on behalf of her? Okay, so I think we should move forward. So next we have Shubh Agarwal. Are you present, Shubh?
Oh, yes, ma'am.
Yes. So he is here with us to present his paper titled as S3FRT and ICT Framework and Prototype for Translating Scope 3 Emissions into Financial Risk Metrics under NGFS Carbon Price Scenarios. So Shubh, are you ready?
Oh, yes, I'll just present my screen.
Yes.
Oh, is my screen visible?
Yes, it is visible. You can start.
So good morning, ma'am and sir. I am Shubh Agrawal along with my co-author, Jay Barnecha. So first of all, I would like to thank ICT4SD for giving us this opportunity to present our paper. So our paper is titled S3FRT, which is an ICT framework and prototype for translating Scope 3 emissions into financial risk metrics for different carbon price scenarios. So basically, what we are trying to explain with this paper is, in simple words, what does a company's carbon footprint actually cost in dollars? So let's say a company emits X amount of carbon emissions, X amount of metric tons of carbon. So what will be the financial impact of this on the company? So this is the paper. So moving on to the problem statement. So firstly, I would like to start with the apparel industry accounts to around 4% of the total global emissions. And in those 4% of the emissions, 90% of it is scope 3. So essentially, in all the carbon emissions which happen globally, there are three types, which is scope 1, scope 2, and scope 3. And out of which the scope 1 and scope 2 are the direct emissions, and these are 10% and can be very easily calculated. The problem is with the scope 3 emissions, and these account for more than 90% of the emissions, and it is extremely hard to calculate. And another important point is in 2025, the EU government released these two framework, which is the CSRD and the CBAM. So CSRD is Corporate Social Sustainability Reporting Directive, and these frameworks mandate all the companies in European Union to disclose the carbon emissions. But another important problem is that even after disclosing these carbon emissions, there's no way for the company to find out what is the actual impact that these emissions will have on their finances. And I think finances is one of the most important things to any company. And if they cannot really figure out what is the financial impact, then what's the point of disclosing the carbon emissions? So that is a problem statement. So coming to the research gap and questions. So after conducting a thorough literature review, we found out there were essentially two tracks in this domain. So the first track was papers which spoke about scope 1 and scope 2 emissions and their financial impact. So this was the first track. And in the second set of papers, we found out there were papers regarding the measurement challenge of scope 3 emissions. But there was no study which talked about scope 3 emissions specifically and their financial impact. So with this, we basically have taken three research questions. So the research question one is, can we build a systematic method to turn scope 3 emissions into quantifiable financial risk metric, as I explained? Then the research question two is, at what carbon prices, at what time horizons, and for what emission categories does cost become material under these specific EU frameworks, such as CSRD and CBAM? And research question three is, what does the current disclosure practice reveal about the need for standardized independent verifiable methods? So moving on to a main contribution for this paper, this is a S3FRT framework. So S3FRT stands for Scope 3 Financial Risk Translation Framework. So we have four steps basically, which is step one. In step one, we basically take the disclosed Scope 3 emissions and we take it as an input to our model. In the step two, what we do is we perform carbon price mapping. So in carbon price mapping, there's a database called NGFS, which is maintained by European Union. And it basically has carbon prices for different scenarios for different years. So the CSRD and CBAM has three different scenarios, which is current policies, delayed transition, and net zero 2050. So it is a goal of the European Union to reach net zero 2050, to reach net zero carbon emissions by the year 2050. So these are three different scenarios for four different time horizons. So in this, we figure out these scenarios which we want to take and the year which we want to calculate for. Moving on to step three, which is the financial risk translation. So this is the most important step. So basically, there are three formulas, which is carbon tax liabilities. So this is the actual, basically cost in dollars, which these carbon emissions will cost to the company. So let's say a company has X amount of metric tons of emissions. So using this formula, we will figure out how much will the company has to pay to the government to equate these emissions with the CSRD framework. So this is a carbon tax liability. Then we have EBITDA sensitivity. So what is EBITDA sensitivity? So EBITDA sensitivity is basically the percentage of all the operating profit the company has to kind of use up to pay for these emissions. So the higher the EBITDA sensitivity is, the lesser will be your profit. So that is the concept. Then the third is cost of capital uplift, which is pretty straightforward, I guess. Moving on to step four, tier propagation. So when we calculate scope 3 emissions, you also take into account the risk which comes from our upstream suppliers. So let's say I'm an apparel company, I will also take into account the scope 3 emissions of my supplier. So let's say I have a supplier which supplies me fabric or buttons. So I will also take into account their risks. So that is why whatever cost we get, we multiply it by 1.15, increase it by 15%. So coming to a prototype, so this is the data and sample that we have taken. So we have basically studied 18 companies, and these 18 companies cover basically four market segments, which is mid-price apparel companies, sportswear apparel companies, luxury apparel companies, and fast fashion apparel companies. And the sources we have, those sources that we've taken, I've mentioned it here. These are the sources. These can be verified. Then two companies we excluded because their category level disclosure was not available. So there are also something called as categories in scope 3 emissions. So there are a total of 12 categories, and we need those distinction between those categories to accurately use the formula. So it was not available. So these two companies we excluded from our study. So coming to our results. So this is the result one. So basically what we are doing is we have taken the scope 3 disclosures, as I said before, in the first step. So let's say Nike has 9.74 metric tons of carbon emissions every year. Then Adidas has 6.50. Then we have figured out the carbon tax liability. So our mean scope 3 emission came out to be 2.53. Then we Then we took this value, which is $183, which came from net zero 2050 in the year 2030. Using this, our carbon tax liability came as $372 million. Then our estimated shortfall our EBITDA sensitivity percentage came as 25.71%. Now, another important factor that I want to take your attention to is the 5% materiality threshold. So all these apparel companies have something called as a materiality threshold. So materiality threshold basically explains the investors how the company is performing. So if your materiality threshold is above 5%, which means your company is in a highly risky zone because the carbon taxes are way too much. So most likely in such cases, the investors usually withdraw their money back or no new investors invest in the company. So no company should exceed this 5% threshold. And in this study, we found that 16 of the 18 firms exceeded this 5% threshold when we take into account the new regulations which will come in 2030, which these companies are still not prepared for. So this was the first finding from our analysis. So here we can see that most of the companies are above the 5% materiality threshold. Another important point is that I need you to focus on two companies, which is Nike and VF Corporation. So VF Corporation has around 4.43 metric tons of carbon emissions, and it has a EBITDA sensitivity of 96.04. But Nike has an carbon disclosure of 9.74, which is more than VF Corporation, but still its EBITDA sensitivity is lesser. So the lesser the EBITDA sensitivity, it is better. So why is this happening? Traditionally, what will happen is the more scope 3 emissions you have, the more EBITDA, the more profits you will have to give up for paying the taxes. But that is not what has happened. So this is another finding, and this is also a very important finding. So in this, we have basically figured out that emission volume is not a really good predictor of financial risk metric. Instead, it is a margin which actually helps the company to figure out what will be the financial impact of those emissions. So companies which have a higher EBITDA margin have a
Shubh,
lesser sensitivity. Yes.
just a quick reminder, you'll have to wrap up within next 1 to 2 minutes.
Oh, yeah.
Yeah.
So this is our second result. Moving on to the result 3, the delayed transition cliff edge. So basically, it is recommended the companies use the net zero 2050 to figure out their emissions. Otherwise, if they use the current policies, their ratio will suddenly increase from 1 to 9.73x from 2030 to 2035. Although I'll just speed this up. Coming to validation and policy implications. So essentially, what we have done is we have done the Puma control compatibility test, from which we found out that the Puma's own disclosed range is very close to our range, which we estimated using a framework. So this was the first validation. The second validation is for the four internal consistency checks, which were boundary conditions, linearity, monotonicity across scenarios, and scenario divergence. Then we also performed sensitivity checks. So that was also passed. Then another important point was the disclosure gap. We found out that 15 out of the 18 companies do not calculate financial risk at all. So that is very important. After 2030, it will become very important as they disclose these emissions. Coming to the conclusions and future work. So the future work is real-time NGFS price feeds, then ERP-linked scope 3 data pipelines, cross-sector benchmarking as CSRD reporting scales up from 2025. And yeah, I think I've answered all the 3 research questions which I've mentioned in the beginning. And yeah, thank you.
Okay, thank you so much, Shubh. Devraj, sir.
Yeah, I
You
don't
have
have
any
any
question?
question. Yes, Sita, I don't have any question. Thank you.
Okay, sure.
Thank you.
Thank you, Shubh. Okay, a last call for Mehak Agarwal. It's a last call for Mehak. Are you ready? Is the glitch solved? Okay, so we are here with the last presentation for today. So we have Durga Ghute, to present her paper titled as A Comparative Study on Customer Perception and Trust in Digital Payments versus Traditional Banking Channels. So, Durga ma'am, are you present?
Yes, ma'am.
Yes, you can start, ma'am. I think your mic is muted. We are not able to hear you if you are speaking anything.
Yes, ma'am. Good morning. Good morning, ma'am. Good morning, sir. My name is Durga Bhute and I'm from Varda. And my audible, ma'am?
Yes, you are audible.
And my title name is A Comparative Study on Customer Prescription and Trust in Digital Payment via Traditional Banking Channels. And my college name is Faculty of Commerce and Management Science, School of Allied Science, Datta Magi Institute of Higher Education and Research, Savangi. Presented by me, Durga Bhute. First, introduction. Digital payment systems have transformed modern financial transaction by offering fast, convenient, and cashless payment options through UPI, mobile wallet, and internet banking. However, traditional banking channels continue to be trusted for their security and reliability, and customer prescription and trust play a curricular role in adoptions of digital payments. And this study compared to customer prescription and prescriptions study and trust in digital payment system with traditional banking channels based on ease of use, convenience, and security and overall trust. And literature review. Trust-driven digital payment adoption, security, and ease of use build confidence and service quality, improve satisfactions to customer, and younger user prefer digital payments. And fifth one is traditional banking is more trusted. Digital payment are more convenient. Then objective is to analyze the customer prescription regarding ease of use, convenience, and security digital payments. Compare traditional banking channels. And easy way, an easy way an easy way to traditional banking in use, and to assess the level of customer and digital payment platform versus digital traditional banking system based on demographic variations. And hypothesis knowledge, no significant differences in customer prescriptions, and alternative is significant differences in customer prescriptions. And then demographic factor is not of no do not affect the trust. And then fourth, demographic factors affect trust. And data is primary data, and all data is primary data is collected and through structured questionnaires. And 186, and descriptive statistic used to summarize respondent prescription and trust level. And one-way analysis applied to compare customer prescription across demographic groups, and levels uh, significant levels used to test hypothesis, and resulted interpreted and using f value and p value is determined statistical significance. And
findings, digital payments are easy to use, old and younger, and any time in use to digital payment. And 24 hours is available, and transactions are faster than the traditional banking, and increase and day-to-day increase in digital payments, and most users trust in digital payments if older than younger, and security prescriptions varies among different demographic groups, and digital literacy affect confidence. In conclusion, digital payments are widely accepted and trusted, and most customers have similar prescription of digital payments, and security prescriptions differs across demographic groups. And fourth, digital literacy influence customer confidence and handling payment issue, and awareness and digital literacy program can improve adoptions.
Durga, I think your mic is not working. Your voice is not audible.
Then reference and then few references. Then thank you. Not many questions.
Yes, Debraj sir, do you have anything to say?
What, ma'am?
Debraj sir, do you have anything to say? Okay, thank you so much, Durga. You can
Thank you,
stop
ma'am.
sharing. Yes, thank you. So it's a last call for Mehak Agarwal. I am able to see that you're present. So if you want to present, this is the last chance for you. Mehak, are you listening? Is any of our co-authors here? Okay, I think there is some glitch still. So we are at the end of the session. Okay, so as we have come to the end of this session, I sincerely thank all our authors for their excellent presentations and valuable contributions, and all the participants for being an important part of this international conference. So, I truly hope that this session was very insightful and engaging for everyone. So, on behalf of the entire team, we thank you for your continued support, not just for this edition, but for all the previous editions of this conference. So we look forward to welcoming you again in the next version in 2027 as well. So all presenters will be receiving their digital certificates through email within 2 working days. The publications will get live within 7 to 8 months. So we kindly request your cooperation with our team. I would like to sincerely extend my uh, thanks to our session chair for expertly chairing this session. Thank you so much, Debraj sir. And this is a small token of appreciation on behalf of the Global Knowledge Research Foundation and partners. So, thank you all once again for your valuable presence. And before we officially wrap up with this conference, let's capture a quick memory. So, I kindly request everyone to please switch on your cameras for a group snapshot. So, everyone, please turn on your cameras. Yes, everyone, please turn on your cameras. Okay, 1 second, I will click a snapshot quickly. Okay, thank you so much, everyone. Stay safe, take care. Thank you for joining.
Thank you, Ishita. Thank you very much.
Thank you.